My name is Christopher Carrick. I'm the founder of the company, Lignin Industries. And I would like to start off with our vision, which is a world where sustainable plastics are the norm, not the exception. I think it bears a lot of mindfulness in that sense. And I think there is a lot of resistance to this change today. What we do in our company is what you see on the picture. We modify lignin chemically, and we produce thermoplastic lignins to be used in ordinary plastics. So this is the most complicated slide I will start with, so bear in mind, this is explaining two industries in one slide. So the slide to your left describes the plastic industry. Today, the plastic industry is about 400 million tons in size. And it's 99.5% made out of fossil fuel. We are getting better and better in recycling. About 9% of that flow is made from recycled plastics. It's quite low, in my opinion. It's still very low. I think in about 30 years, we have tried to really harness the power of recycling. We have failed tremendously. And I think the first journey of that was when it was peak oil and oil was supposed to run out. It did not happen. So now we're on that topic again. I think what has also happened is this bio-based type of plastics. It's 2 million tons, made primarily in Brazil or US. Not much is produced here in Europe. The expectations is for 2050 is that I love plastics, and it's growing. It will triple in volume by 2050. And this is believed still to be one of the largest challenges when transitioning from a fossil dependency to a bio-based society. There are no real scalable solutions. And bio-based is one of those that will absolutely grow. Recycled as well. The theoretical max is 60% will be recycled. I don't think anyone in the plastic industry believes in that, but that's the theoretical max. Then matching this, and this is coming back to Marcus Wallenberg, what you said in the early days, with where is the future? Where will the forest industry or the biomass industry grow? If we look at wood, I'm overestimating 180 million tons of lignin is processed every year in the wood and forest industry. What we miss, what we typically underestimate is the amount of lignin that is actually used in the agricultural industry. This is the waste flows, the bagasse, the barley and other types of lignin that is annually produced and processed in the world. So lignin is everywhere, is what I typically say. And typically in the history, we have focused on this type of lignin source. However, in rice, in wheat, in corn and bagasse and soya beans, there are a lot of lignins available. And there's a lot of cellulose and hemicellulose as well in those raw materials. So this is what I'm telling Brussels. The raw materials, the biomass gap is not really existing. We have a lot of raw materials to compensate in this journey. So what we do in our company, we are buying lignin from forest or agricultural industry. I think, Hanna, you touched upon this. This is the one thing the forest industry needs to handle is the odor. And I'm not telling you that this should be odor-free, it's odor control. I brought some bags here as well so everyone can smell what it actually, a plastic smell would look like. And that comes from the craft process itself. So when you're processing this in terms of, from an agricultural way of processing biomass, you do not have the craft process, which actually generates a complete different smell on your plastic that is actually amusing or nice. What we do is we react in this in an epoxidized oil, a natural oil, and we generate a thermoplastic lignin that can melt and be shaped and solidified into a material that we call Renol. We then make it easier for the plastic industry. So what we're doing is we're bridging the forest or biomass industry with the plastic industry. So we're mixing this with a little bit of target polymer, which is polyethylene, polypropylene, or ABS. PE and PP are the two most commonly used plastics in the world. So they are everywhere. And then you take this thermoplastic material of lignin and some carrier polymer, and then you introduce that straight into the plastic industry and producing bags such as an e-commerce bags that I brought with you here. This has a white top layer without our material, and it could be brown inside or colored inside. And then, so this is also key of what we're doing. We don't want to change the infrastructure of anything. We simply want to make something that works within the plastic industry as such. No change in temperature, no change in processing volumes. The nice thing here is end of life. All the customers we are working with are obsessed with recyclability, which is a good thing. When we are designing our formulations, they are recycled in the open recycling industry. It's not a closed loop type of recycling, meaning that our products will be identified as PE if we mix with PE, and then sorted as PE and regranulated as PE and still functional as PE. Super important. So end of life, and recycling is working for us as well. Moving on. So this is where we now are starting to take market shares. We are producing 2,000 tons outside Knivsta, Arlanda, in our factory. Primarily, we're growing here in the e-commerce bags, so the type of items you will get home when ordering online. The reason for that is that these brand owners are typically in this field using recycled plastics. A lot of those has gone over to paper bags due to a belief in sustainability when shifting from recycled plastics to craft paper. Issue they're having is that these bags are water sensitive, harder to print on, and are more volumetric. So logistics is more tricky. And also the gain in sustainability is challenged. The reason why we targeted this market, we want to get rid of the recycled plastic and start to introduce something that's more sustainable to recycled plastics. But what happens in the brand decisions is that the unit there is 40 grams for a plastic bag and it's 100 grams for a paper bag, meaning the paper bag is 2.5% or 2.5 times the plastic bag in price. So we're matching or slightly south of the craft paper, meaning price is super important. So we're cheaper than the paper bag. And that's why we're taking the early volumes from paper rather than plastic. I think that's something we could perhaps surrender in the short time in the paper industry. So the bags that we're doing, so this is our product, the granulates. Products that then is made is this e-commerce bag. Then we're doing, this is a cable hider that we're doing for the UK market. We're also doing Scania trucks. We're actually now taking off the box for making trucks out of our material. We're doing shower units now for the UK market. Just one shower unit in UK market is 200 tons. Just for the UK market, one shower unit. So once you enter the market, each item is quite large in volume. And this is PP. This is our strongest candidate. We mix in up to 40% of our material, preserving material properties, and then you can have a range of different colors. This is in the piping and construction industry that we're now launching as well. This is just giving some love back to Mr. Wood. You said it yourself, and Mr. John Ralph. The complexity of lignin. So we have worked with 35 different lignins. I think this is 25 different lignins. And now I have rated them, so different source, different processing conditions. So we have built up a lot of knowledge on lignin, and we've been told about this, my quality of lignin is the best, and so forth. So when we are doing this, we arrange it so a standard ABS plastics is about 17.5 in impact strength. So the impact strength is in the y-axis. We end up with a variety, so this is mixing the same stuff, about 10% of modified lignin in ABS. We have the range from 5, really deteriorating the ABS quality, or we have 25. So doing the same stuff, but with different lignins, generate very different results. And in order for us to understand this, we need to go back to the structure and the miscibility and the fundamentals of what lignin is. So when we are, this is just in order for me to complicate this even further for us. So when we look at extraction methods and trying to understand, is the process method, is it the raw material, is the quality of lignin, what is important? What we have been told before reading your stuff, we have been told that organosolv is the purest and best lignin you could ever buy. And before reading what you've done and the importance of the composition of lignin, the characterization, what's it built up of, one would have thought that in an ABS that the purest lignin would gender the best results. This is the worst lignin, lignosulfonates. It's about 30% of ash content. And we generate typically the highest performance in ABS. We have done this. This is only ABS. We've done it with polyolefins as well. The same type of fundamental study on where do we buy the lignin and what influences this. So coming back to miscibility in an ABS system or miscibility in a polypropylene mixtures, it comes from the chemical structure of lignin rather than the amount of ash that it contains. So the industry start to perhaps design for fit for purpose lignin is what I'm trying to say. Just touching base on what lignin, it says Renault there in the headline. It could say lignin as well. So utilizing the entire tree, this is where I come from. This is where I believe the oil refinery has done beautifully. I think we could do the same in the biomass industry. Drop-in, this one thing I would like to highlight. I've already highlighted it, but what we are trying to do with lignin is basically to feed the oil and gas and plastic industry with a different raw material. Instead of feeding it with oil, start feeding it with lignin and then go on and do your products. And with that, I would like to thank you.